Alrighty, friends, I'm going to give this another go. Computer's kind of running slow, so bear with me. This video is kind of similar to the one that we just did with the segment addition. And how it's similar is that the angles that you're going to be given aren't a part of the triangle. So whereas before the sides that we were given weren't really a part of the triangle, they were too long or too short, now we're going to be given angles that aren't in our triangle. So I wrote down our first given. It was that this angle was congruent to this angle. We could prove that we have parallel lines because we have alternate interior angles congruent if you write shape. But looking ahead, now that I've got this reflexive side, I'll be able to get angle side. So I'm just going to take the, if I took it as a freebie and I still didn't have it, I can come back to it. That's what you should be kind of be thinking here. But for our next, we've got that EAC is congruent to JDB. Now, these angles aren't a part of triangles yet. Let's say that this angle here is 130 degrees. Oh, come on. There we go. That's 130 degrees. And since these are congruent, this must also be 130 degrees. And if you think back to Unit 1, we've got linear pairs here. These two angles here form a line. So that means that their angle measures have to add to 180 degrees. So if this one is 130, then this angle here must be 50. And it's the same thing over here. If this angle is 130, then this angle must be 50. And if this angle is 50 and this angle is 50, that means that these two angles are congruent. So I'm going to add another line in there, even though the color can kind of differentiate them. So we've got this angle is congruent to this angle. So I can check off both of these givens because I've written both of them down. We've got these angles congruent. And that's the linear pairs piece here. If you've got an angle that's outside the triangle that's congruent, then their linear pairs are congruent. Because if this is 130, this is 130, and that has to be 50, and that has to be 50. Now, the last piece here, I'll write down the theorems and resume the video. Alrighty, so there's the theorem. Congruent outside angles create congruent linear pair supplements. So BAC is congruent to CDB. There it is, folks. Alright, so we've proven two parts of these triangles congruent. We have an angle, we need a side. It can either be this side, or this side for angle, side, angle, or angle, angle, side. If we're looking at this, though, we've got the reflexive property right here, folks. And remember, the only two things that you can get from the diagram, reflexive property, vertical angles. We've got the reflexive property here. So pause the video, look through your definition sheet, find where it's talking about the reflexive property, see if your conclusion will be the same as mine and the given in the theorem. So here's my given in diagram, shared side BC, reflexive property states that a segment is congruent to itself, and our conclusion is that BC is congruent to CB. The reason I switched the letters again is because first it's BC, it's the second letter, then third letter. So over here we have to do the second letter, then third letter. So BC and CB. Now we've got three parts congruent. So think about what type of triangle congruence we have here. Write down the theorem, write down the conclusion, see if it's the same, and we'll be good to go. I've written down our theorem. We've got angle, angle, side, congruent to angle, angle, side. So we have congruent triangles. So our conclusion is that triangle ABC is congruent to triangle DCB, and that is what we were trying to prove. If we were trying to prove other congruent sides or angles, then we'd say the piece about congruent corresponding sides and angles, blah, blah, blah. But that's all they wanted. So that's it for segment, subtraction, addition, and linear pairs. Briggs out.